Hello and welcome once again to Steve's Vintage Radio Long Stay Workshop, which also does tape recorders quite often these days. And I've got a question for you. When is a Grundig tape recorder and not a Grundig tape recorder? Well, not really. In the 60s, after made things like the ZK140, 24 and so on, and the 14 and the 35, which they did recently, Grundig outsourced manufacturing to ZRK in Poland. Now, ZRK in Poland were also people that worked with the Unitra brand, of course, which was quite popular over here, and there's something which I'm very fond of. So this, which is in a bit of a state, but I'm glad I've got one, is the Polish version of the Grundig's ZK140. It is, of course, 4-track, or both together. Everything is on this here, like that. As you can see, the wheels move about when it's like that, you see. That's okay. And so, this is the Unitra version of the Grundig in question. I think it's valved. I can see it's got what appears to be a EM84 or 87 in it, and so it looks to be perfectly within our capabilities here, I hope. So let's have a little look at a little see, shall we? Because it's an interesting machine. The plug, of course, is not something which we can use over here. I'll deal with that in the usual way, which is, of course, by doing this. Like that, and that can put my collection of plugs over there. And of course this can be separated and made to operate. With these tape recorders, it doesn't matter if the thing is transformer driven, which way around live and neutral go. This should be transformer driven, I hope. But what I'll do, I'll get this ready, and we'll plug it in, and we'll see what it does. Because I know people say I shouldn't. I've had it said to me at a few fairs actually, but in actual fact, I like to know where we're starting from, even if it's smoke and fire or nothing. I like to know where we're starting from, because then, of course, we're not changing parts and stuff, and the machine's not going to work anyway, which I have done in the past. So it's very important. By the way, at the same point, don't just change capacitors willy-nilly. It's not a good idea. Look first and see what they are and where they are and things like that. This one has got all sorts of stickers on it. Normally I'll remove them, but in this case I won't, because they're obviously foreign, and on top of that, therefore the history of the machine as well. Some of them actually quite, I mean, in dark colour. I don't know quite what that is. Hang on, I'll just bring forward and check. Hang on. I don't know what language that is, but it is Coca-Cola. I don't know what that one is, if you can see it. And the two on the side, again, I don't know. But I think it's important to keep things like that in place. So I'm going to see if we can do that. But if we do anything else, I'm going to make this wire suitable, put it on the safe block, switch it on, and see what happens. Right, well, let's go. Now, on-off volume is this one here, so doing something. That's okay. That's okay. that sort of is and isn't. Okay, so know that the belts are doing something. Now also I've noticed here that there doesn't seem to be anything on these controls at all. I don't know whether this should be lit or not. I switch it to record, which I do by holding that down and turning that, which is a bit of a challenge with my hand, but we'll try our best. I think we're doing that, is it? Okay. Well, I'll put it down, and it still doesn't do anything. And I don't see a heater behind that either, so this tape recorder might have something serious on the power supply side wrong with it. I'll just quickly get a tape and we'll see if it's one of these where it doesn't come to life until you put a tape on. It's rare, but we do get it, so get a tape and we'll try it. Right, well, let's see, shall we? I'll just do a touch of that for now while it that doesn't do anything, that does it? Now there could be a number of reasons for that. Some are quite simple, some not so. So power off again, and let's have a look inside and see what's going on. Now on this machine, on these Grundigs, although this isn't actually Grundig, it is but it's not, like I said earlier, it's a Unitra, but the same applies. So what we do, screws out as always. That's loose, that's worrying. And one of these ones that they came in, it had no electronics in it at all, so I hope this isn't going to be like that. Yes, these things do happen in this club, believe me, they do. Especially off eBay, so you know, watch yourself. Let the buyer beware and all that, so you know, they can't actually do anything about it. Although eBay probably would actually, because they do seem to favour the buyer over the seller, which is not a best way to be, because if you don't protect the sellers as well, then you won't have many sellers, and without sellers there won't be buyers. So something which they need to think about. Something else here that's holding it. Well, the electronics are all in, the valves are in place, so that is in our favour at any rate. But again, why is it not making anything that it should make, like noise? I don't know. No, it's not. Okay, not to worry. At this stage, what we've got to do now is just look around and see what's what and what's where and what's who and everything else, you know. Because that is important. So I put that over there, and it's sticking and stuff. There we go. Power it again. And see if any of these valves light up down here. What that one lit. That one is it? Okay. And this one is lit. Okay, fair enough. So the heaters are there, but nothing else. Okay, so we know that the heaters are there. We know that many other things aren't, so I'll put that back on for now just to see what we're packing here. These are quite similar actually in some ways to the BSI dates in the UK, but that is where that ends, believe me. Right, okay, well, yeah. Right, next thing we do is check for any HT. And luckily with these, there's a place where you can check, and it's quite convenient. So that goes down like that. That goes to deck somewhere. They'll do. And we'll go and have a look around here and see what it's doing to us. Nothing. Okay. .3 volts. Well, some decibels. Yeah, and yeah, so we're obviously not doing anything. The volume control, again, there's nothing at all on this. So the fault on this is quite simply no HT. Now, no HT could be for a number of reasons, quite a number of reasons, and so I think the next thing we do here, knock that off like that, is see if we can find out where and how and everything else that we get as all we have to do here. So yeah, is that? Let's try there. Let's try there. That sounds like a smoothing cap. I don't know if it looks like it, so we'll. So we'll try it. Hang on. Nothing. Nothing anywhere. Nothing anywhere at all. Okay, fair enough. Right, into it we go. Now that you see, this here is the rectifier. So that and that. Should do something. Yes, okay. Other way around. Yeah, that suggests that something is wrong. That's a dead short. That. Now, like I said, there's it might be from the mains transformer. So with it plugged in again, like that. Not just yet. We go that onto there, like that. Switch on. And this onto here, like that. And again. I don't think 2 volts is enough for me, do you? Right, okay. Right, so we've got a problem here, I think, haven't we? So what I'll do now is I shall take these two leads off, and we'll see if the short circuit is here or further back. But first of all, I'll very quickly nick that off, because that might be the problem. So now when it goes again, and we'll see now if there's any heat in it now. And again, doesn't look like there is. Oh dear. Have we got a winding faulty down here? Possibly, isn't it? But what I'll do, I'll very quickly now do that, and we'll see what it comes up with. Okay. Right, well, very quickly, and we'll very quickly and very carefully take that off there like that, and that off there like that, and again, I'll make these leads spare, and we'll see if it if it's got any voltage on it. There should be, but we don't know for sure, do we? So we have to check, don't we? So that one goes onto there like that. The other cord goes onto, you see, because that goes onto there like that. You see, so that goes onto there like that, and this now goes onto there once it's been bed. Hang on. Okay, right, so okay, so now that is now going to go onto there like that. Okay, be like that then. Okay, well, more than one with the killer cat. There's not a lot there either, is there? Actually, there is absolutely 56 volts. That is not enough. That is not enough by any stretch of imagination, that 56 volts. So we'll find out where that goes. If it's part of that transformer, with the motor still working okay, then that's a wiring transformer, which isn't a great problem, but you know, sometimes you have to do this thing, don't you? So so these go here, and that goes to there. So they go to here. Okay, fine. So it's this here. So again, on it goes again. That goes on to there. 284. Ah, so that's okay. That's okay. Right. And this is a fuse somewhere on this back panel. This is a fuse somewhere on this back panel. But having said that, I might change that anyway, because they do actually tend to lose voltage over time, so I might change that out anyway. But check the back panel first and see if there's anything on there which could be a problem. Don't appear to be, actually. There does not appear to be anything on that back panel that could do this. So yeah. Okay. Okay, well, we know that it's there. We want that here. So what I might do in the meantime is do what it says. Simply put these onto there and hope that that brings it out. As far as fuses are concerned, well, there's one in the plug, and yeah, there should be something here, but obviously there isn't, so yeah. Okay, let's have a little think, shall we? Right, okay, so we've opened up what we're meant to do, and so let's do a bunch. What I've done here now is I've joined these two wires together here, and now from there to here we don't have a bleep, but I do have voltage going to the transformer. Okay, so now if we switch it on again to like that, yeah, and then I'll put that to that like that, with that in there, thank you very much. $280 volts. Okay, right, so now of course now I'm not going to put those back on there straight away, because that might be faulty. But one thing that probably is faulty in this case, actually, it does happen a lot more than you realise, is feeling capacitors tend to break down. So what I'll do now very quickly, again I'll turn it around so you can see. There you are. So it's there, okay. So now we're going from earth to here, and we'll see what it looks like. That's okay. Okay. So that is came to about 35k, and this one is about 37k. And we'll quickly check that resistor, because that's the next thing. So that goes onto there, like that. This goes onto here like that. And this is about 2.1k, so that's probably alright. Okay, so now another thing we'll do very quickly. There's no shorts on the output side of it, obviously, otherwise, as we've seen them there. But the input side of it, again, we'll check. That's here, okay, so it's first of all, we go across the pins and see if that's doing anything it shouldn't or shouldn't do. So that goes onto there, that goes onto there, and it doesn't tell me a right lot. Notice that. Okay, well, try it on dial check. Sometimes these don't show up on a dial check, by the way, so be ready for that. Try it another way around just to prove a point. Nothing, okay. And so that goes back onto there. This will go to there, okay. And that's worried. Yeah, I'll change that. I'll change that. It might be better if I put something else in there because I'm not too happy with that. And for the cost of a new component, it's neither here nor there, you know. So I'll change it. The old bid's out of the circuit and the new one is in. So now, if we go across these two pins here, we should get a good healthy DC reading, which we do. So we know from that, switch it off first I think, that that one is okay. That one I don't know about, but I'm going to whip it out anyway and put this in its place, just for well, it seems a good and reasonable thing to do. So this now goes into the circuit and of course onto there. Now this thing here is held in by these two screws here, okay, there and there. So we just whip these two out if we can. Come on. Okay, I'll just do this off camera. I've not put this in yet because I think there are one or two other problems as well, which I shall demonstrate to you now. First of all, that goes to deck somewhere. That'll do. Yeah. And this sort of here goes to 285 volts. Okay, fine. So we switch it to play. And oh dear, oh dear, oh dear. That does not sound good to me. Or you for that matter, take it. Anyway, what you can do in this situation, the thing to do. Now that's interesting. Now that's interesting because it's not actually, that suggests to me that it's not actually smoothing capacitors. And I say that because when that goes down to 0, so does that. Okay. So it's something with these buttons here, because if it was smoothing cap oriented, then it wouldn't actually drop with the volume. So that suggests to me that there's a fault somewhere else. And with these, the Grundig ones and the Unitra ones, there is a little problem with these actually, with the buttons here. So now I know that they are probably okay. Then I will go and look at that. So I'll put that in place neatly, and then we're going to have a look at what is and what isn't over here. Right, now here's the circuit of the tape recorder in question. First of all, on these, the transformer and the motor are all in one. It's here, and if that fails, if it works to the motor, then there's no trouble. You put a transformer in. If it works as a transformer, not a motor, you've got to find a motor of the right speed. So yeah, and also from that, you know, the rectifier, the mid rectifier is here. Yeah, like I said, the two, the home problem on it, if I was to switch on like that, is not down to here. If it was, then it wouldn't vary alongside with the volume, but it does, as you can see here. So now what I'll do, I'll put this thing back into place, and then of course we'll look at the deck, which I think might need belts, but we'll have a look. Anyway, it's a standard tape recorder circuit, as you can see there. I've got ECL86 and an ECC83, you know, and I said there are only 2 valves there, but 3 on here, so it might not be the right one, but it appears to be. So we'll see about that. Like I said, the ECL86 is here. Output transformer is here, and so you know we should be able to get something working out of it. I hope. See what the deck does, shall we? First of all, go forward, which is doing moderately well. As you can see here, it seems to be doing okay. Okay, so now what we do is you know, turn these over like that. Like so. Put the tape through there again like that, and see if it does the same on rewind. That's okay, fine, yeah. And this way. Oh, okay. Well, that's okay anyway. So the deck therefore takes like that. So the deck therefore needs something doing to it, obviously. So we'll take the tape off and clean it and see if it belt. Actually, there's one belt on here which probably does. Yeah, it does actually need to be worked on. So yeah, these decks work in a similar way, as far as belts are concerned, to the BSR decks. In that you know they have these. There's a motor this there, and it drives your rewind directly, and I'll take that off, and does rewind, does time followed by this here. So first of all, that's fast forward. No, that's rewind there, yeah, and that's fast forward. So I think first of all that needs a bit of a clean there. As far as the play is concerned, it doesn't actually carry much, but at the same time it does. The thing is, that works okay, but go underneath there, even with that hold down like that, that's going under there. So next thing therefore is have a good look at this deck and find out where and how and things like that. So first thing to do therefore is give it a bit of a clean. When you take something like this apart to clean it, there are one or two things that you must bear in mind. First of all, unless you know exactly what you're doing, which leaves me out, always take out only one spindle at one time. Okay? Now this deck, like many others, they take out these here. Here. Yeah? So we take that out there carefully, and then when we turn it over, that spool should lift out. Okay, that's pretty obvious. It looks like it's the take up. It's the take up spool, but it's going to come out for two reasons. One is the fact that it'll give you more space to work, and two, I think that it might be possible with these various holes to change the drive belts without taking the heads and that lot off on top, because when some of these, when that happens, the whole lot falls down. So and yes, I have had that problem, and yes, it's difficult. So first thing we do therefore is put one's glasses on, because one is old, like so. Okay, and look in here and see this. Now this comes off here. This comes off here, and always take these things off very slowly. Otherwise, they'll fly off, and you won't see them again. And you do need them to put back in. So you know, you don't ever risk taking them out by force. Never. Because if you take it out by force and it flies off, like I said, you've got to find another one or something that will do, which is one of those things which you'd rather not have to do. So, you know, like that, okay, and this here should come off in the end. It takes time, but always make sure, whatever you're using, always make sure that it comes off and doesn't actually try to fly off, because believe me, Murphy's law states that anything that can go wrong will, and Sod law states that this will fly off. So be very, very careful with it. It's coming, but you've got to be very careful with it. Otherwise, you will have a little bit of a problem. That was harder than I imagined, because that came off. Well, that came off, which is a clip. Then that was underneath. If you feel like putting it on camera, there you are. That was underneath that, and then of course there was that as well. So now, if we turn the tape recorder over, we should be able to take out the spool in question. And there it is. So that now comes off. Okay, so now that and that underneath comes straight off. It's common on both machines, but that one seems to have taken it a stage further. So now put this back like that, like so. This one here is now missing. Okay. So now I think the next thing we do, we give the whole thing a damn good clean. Put that back on there for now. Right, okay. And as far as getting the getting that through, underneath, I think that there should be something where we can put the thing on underneath and feel it out this way. So yeah. Anyway, so that now comes the goes on there as well. But I just put that one back on. If it will go. So that goes onto there like that. That goes onto there. So all of that needs to be cleaned. While I'm here, there's that and there's that as well. Well, I started the clean up. This came straight out, like I said. This was underneath it, like that, I think it was. And underneath here, there are two, but I think there should be 3 washers. 2 are missing, so that may be a problem. But we'll sort of find something to get in there. But as far as the belts are concerned, that doesn't look or feel too bad. If I can leave that, I will, because it's not something that I really want to get into getting all this lot off, even though it's going from underneath. I just don't really want to, for various reasons. So yeah. Anyway, very quickly, like I said, this goes on here like that, and basically I think it goes like something like I don't know, something like that. Or one of the two anyway. and that goes on the top like that. So that's basically how that goes. If it goes that way, then they must go on there. So that must go probably something like that. Anyway, so first of all, let's give this thing a damn good clean, and I'll leave that on actually to see how strong it actually gets, because that to me looks to be okay. If it's not, then obviously I've got to do something with it. And also, while this is out, I want to clean this and maybe give it a touch of that cleaner as well, touch of rubber renew. So at that point, I will leave it all night, because of course that stuff does need, you know, not to be breathed in. So anyway, so that goes like that. That goes like that. And like that. Yeah. Again, that does feel to be okay, but I don't think it is. I have now cleaned that wheel up, and it spins a bit better as a result. Good stuff this, but I think it's time now for me to go in, because I don't fancy being here with that stuff in the air. So I shall come with this tomorrow. Right, now that's back on there. That's cleaned up quite well actually. So now we've got to try. I don't think this will work on here, because although it looks to be okay, all you need to do is that, and stops it here. You see, everything stopped there, but that is not with pressure at all there. So therefore, this machine requires belts, which I'm going to order. So there's no problem there. But while I'm struggling with belts, I'm going to take all that lot off there, like that. This too, because I'm going to tilt the machine on one side, so I really need to be need to be cleaned. That's been cleaned. That's been cleaned. Okay. So now, while I'm waiting for the belts to arrive, I'm going to make a start on the electronics. Now, these versions with the Unitra on them, they use Unitra parts as well, so they don't use the same parts as the Grundigs. And if I can show you there, you see, if you look there, you see, at the circuit board, these capacitors and things here are all the Unitra types that you get in the Unitra radios of the era. So different components in this, but that's not a problem in one way, but in another way it might well be, because of course I don't know how good these Soviet Eastern European parts are. Normally they're pretty good, but not always. So I'll get on with that next, because that is the most important part. And so what I'll do, switch it back on like that. Yeah, and we'll go to like that, 600 volts or thereabouts. There you are. So that goes to deck somewhere. There will do. And we'll start up here. And that's not doing very much, that is it? Okay. Okay. Let's do that again, shall we? My meter gone stupid. Okay, fine. Well, that's okay. Okay. right there. Okay. So now there should be something. Well, it will be 261, and the other side is 251. So that's about right. Switch on to play, by the way, and that comes on like that, and 280 and 252. So it's obviously about right without the extra resistor which we sometimes have to put in, which is fine because, you know, good engineers are always lazy, and I'm supposed to be a good engineer. So therefore, with that in mind, we look at this board here, which has all the electronics on it. But before we do that, there is something down here that is not doing what it should. So with the power off again, like that, we'll just have to do that, and that, and that, and that, and get it and then back on again, switch to play. Like that. Ah, that's what does it. Okay, fine, well, don't press two together, obviously. There you go. So we know that's okay, and we know the head's okay because we have had it sorted playing. So we know the heads are doing something. So now, with that's okay, we then go to the main board. Belts have been ordered. So at this stage, we then will concentrate on the electronics, as I've said. Now, that's okay, and that's putting out 100 slightly more than it should volts, but we did say it will do. That's the ECI6 which I've pulled out for now. And I've pulled this out because I want to have a look at voltages on some of the pins. Okay, that's why. So therefore, we know that pin 9 on here is the ECL, is one in question, which is very deep. If you're not sure, put the valve towards you, like that, finger on pin 1, turn it round, I'll find out where it goes. And in this case, pin 9 is the one that's easiest to get at. Small mercies. So therefore, we'll go there first of all and see what we can see. And that looks to be okay. Next one along is of course pin 8, which is this one here. That looks okay. So from there it goes through two resistors mostly to C10 and the anode of the trial section of the ECL86 is here. So there again, we look again and we should see what's there. And again, because it's because of that valve, it will be higher than it should be. As you can see there, that's high still. That's okay. think that I might think it's better off to put a resistor in series with this line here, which I'll do on the other side of the board because I don't want to muck about with that again. I've got some 100k, 100 ohm resistors somewhere. One of those will do for that. Anyway, from there, of course, we go back and we go to the ECC83 and the anodes of those are, again, '83, okay. Also known as a 12AX7, by the way. And this one, of course, the anodes are on pins 2 and 6, and the grids are on, we'll look at our pins 7 and 1. Okay, so 7 and 1. Let's see what they're like. Have to live with the valve out if you don't mind, Stephen. There you are. Now it will, at this point, it will be higher. So it's pins number pin number 1 and 6 of the anodes, which are there. That's okay. And 6, which is that one, which is okay. And pins numbers 2 and 7. So there. So 2 and 7. They're okay as well. So this board actually, these components to use that Unitra use at the time seem to hold up extremely well. So that means therefore that none of these valves are in mortal danger of being shall we say, turned into output transformer blowers. Anyway, put the tube back in, and I'm going to have another look at the up here and see what it falls down to. So these two valves go back in. Not often trickier than it sounds. Okay, hang on a sec. Now the voltages on the ECL86 come directly from the bridge rectifier. There's one capacitor there, and one capacitor, I think it's, oh, well, somewhere around here, there, yeah. So therefore, what we need to do, first of all, is check as to whether the voltage there is higher than it should be. If it is, we're going to drop it, because the maximum voltage of an ECL86 is 200 volts, 250 volts. So I want to know what this is here, because if it's too much, I'm going to have to drop it. 289. Yeah. Now, it will drop a little bit through the input transformer, but it will not drop 289 to 250. So there will have to be a resistor put between there and the transformer and this capacitor here. Yeah, very important to do that. So I get one, put it in, and we'll try again. 100 ohms is not enough. It only dropped it from 287 volts to 281 volts. So obviously that will still be overdriving the valves. So therefore we have to look again at it. Okay, so 287 volts there, and it should be no more than 250. Okay, 287 minus 30 volts is of course 247. So I'm looking for a 30 volt drop or so there. Okay, next thing we do is look at the voltages on the valves concerned and add them up. Simple as that. So we go, right, well, take a look, and we go 1.2 amps on both of these here. Yeah, that ECC83. 1.2 amps maximum on there. So that's 2.4 amps there. Not 2.4 milliamps there. Okay. Now then, on top of that 2.4, there's of course the ECL86 tube. The ECL86 also has two valves in it in a way, a pentode and a cathode. Okay, so therefore it's another 1.2 on the pentode, on the cathode, and that is okay, and the pentode side of it 36 milliamps and 6 on the screen. So that's 44, 4.44, 45.2, 46.7.2, 47.6. Okay, and of course when we record it's the EM84 as well. So that, just for the record, is let's have a look. EM84. It should drop it further, but I just want to see how much very quickly. .6, oh that's okay, isn't it? So it's 1.6 on top of that, so it's so it's basically, it's about 50 milliamps. Okay, so therefore we've got R equals V, 50 milliamps, over I. So it's dropping 30 volts, and it's doing it dropping 50 milliamps. Okay, so get a calculator, because I'm lazy, like that, and we go R equals V, that's 30, over 0.05, 600 ohms. Okay, so it's looking for about 600 ohms. Okay, well, we can do that. So get a 600 ohm resistor, put it in there, and all will be well. Now 600 ohms puts it just on the edge, absolute maximum. So I think in retrospect it might be best to go a little bit lower than that, or meaning a higher resistor here. What I've put in here is a high watt 1K resistor. Now with that in like that goes like that. It starts at 297, but as it warms up it should come down, which it is doing, as you can see. No, you can't, can you? Hang on. Try that. Okay. As you can see there. And it drops to 235 volts, 234 volts. That's about right. That's about right. It might drop a little bit more on record with this active, but I don't think so. Not that much anyway. So put that in properly, and then of course that's probably going to be it for the electronics, because all these capacitors in here seem to be all right. I don't know quite what they are, but they seem to be fine. So I'm going to leave them because this is my machine, and I'm going to, because I do collect these Unitra Grundig type models, and so I'm going to put that in properly. Then of course start looking at how to get the belts off without taking everything off the back, because I really don't want to do that. The voltage on the valves is now well within spec, and I've also done now is make that they're meant to be three of these underneath these washers, these felt pads. They're only two, and they're both a bit yoked. So what I've done, I've actually got from Hobbycraft some of these little stickers. They're called 3D foam pads, and there you are. So that's now ready to go back on there. Now, with regards the drive belts on this, a lot of people tend to go and take everything off the top, which is not the way to do it. It takes ages and getting it back together again. Oh dear, you know. So what you do, if you look underneath here, hang on, I'll just move the camera up a bit so you can see. If you look underneath here behind the speaker, you'll find this and two screws. And you take these two screws off, which I'll hopefully be able to do on camera. Hopefully, yeah. Then at that point, this bit will come off here, and you can feed the belts through. Now, in this particular situation, they're not coming off, so I'll have to work on that a bit. But in that situation, there are two belts to be had. They're on the way for this, so you know they're on the way. And what you do is you feed them up in turn. Yeah, the first one goes up is the one that goes between the big wheel underneath here and the motor. Yeah, and the second one goes from underneath here to this spool here, which is a take-up spool. When they're in place, put that back on, and all should be well. The other way to do it, of course, is to take all this off the top here. Take all this off the top here, and to take all this lot off here, and then feed it through underneath. The reason why it has to be done this way is because these two have to go either side of this wheel here, and that's in the way there. So all that's to come off, yeah, or underneath. Now, the underneath way is much easier, and so that's the one which we are going to do here when they arrive, which should be soon. So what I'll do, I'll put this back on here, all this back on here now, and hopefully then we'll be ready for when they come. Okay, heads have been cleaned, so let's go.
2 and 20 now he's rising, and alone he fits to fly.
That seems okay to me. 2 and 3, by the way, should play it backwards to the other side. Is there anything there, of course? Find that in a second. Go forward a bit and try that again. Yeah, that's 2 and 3. That happens, by the way, because this is a 4-track machine and that's a 2-track tape. And so what happens is that the 2 and 3 track on a 4-track machine, when it's printed with a 2-track tape, you can actually hear the music backward on the other channel. You can in this also put the two together here as well, but I failed to see the use in that, quite frankly. Anyway, that's that. And this now is another tape, and what we're going to do now is see what it's like on record. If it's okay on record as well, then really we're at a standstill until the belts come. But having said that, I'll just very quickly show you this microphone. This is the microphone that came with the Grundig version. This is a Tesla microphone. That's the case with Tesla on it, and this is the microphone with a stand on the back, like that. You see, like that and like that, and that is the Eastern version of the Philips or Grundig microphones. So that goes onto there, like that. Thank you very much. And now a little bit slower here. Right, okay. Now on record, 2 things happen. One of them is that these LH60 pentose side of it becomes the oscillate stage. That green light comes on down there, and of course the rest of it works in the same sort of way. Recording tape, it can play off the tape no problem, but I have to record it with a bias signal on it. Usually about 50 kilohertz, so that's why. So anyway, that goes on there, like that. That goes on there, that goes on there, and 1, 2, 3, 4, 5, 5. That's okay there, by the way. 1, 2, 3, 4, 5, 5, 4, 5, 5, 5, 5, 5, 5, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. It's a bit low for that, isn't it? What I'll do, I'll record over that again. It could be microphone, but then again, it could easily be no bias signal. So okay, right. He raises it okay anyway. but it's very, very quiet. It could be for a number of reasons, so we'll look at what those are very quickly. I'll put those up full, or midway anyway, and we'll try again with the recording and see what it 1 2 3 4 5 1 2 3 4 5 5 4 3 2 1 1 2 3 4 5 5 4 3 2 1. It's a bit lacking, that, isn't it? Try it on 1 and 4. See what that's like. One, two, three, four, five, 5 4 3 2 1. 1 2 3 4 5 5 4 3 2 1. That doesn't sound too healthy, does it? That doesn't sound too healthy, so I'll have a... So what you do at this stage, turn the thing off like that. Then we know the head's okay because it plays alright. And it appears to erase okay as well, so that's okay too. Now, therefore, look at the circuit and have a think. If in doubt, always have a think. Vitally important. Another microphone, so let's see what happens. That goes down with my shoulder like that. And that. And that. 1 2 3 4 5 5 4 3 2 1. The green light's moving okay, so that's okay. So let's try everything else. Let's try our best, shall we?
ZK 4321.
Very, very sweet. Did you hear it then? I just... Yeah, that suggests to me that all the plays okay. I'll just put the I'll put the pipes of pen down back on, disapprove that. Like so. It goes back on, there we are, and there you go. So now let's see what that does. That sounds alright to me. So again here we've got a problem, but where the play is okay, but the record most certainly is not. I didn't think it would work with either microphone, to be honest with you, after that. So you know, it's one of those things that. So you know. Anyway, from there, with it off, let's have a look at the circuit again, shall we? Which is here. I just get up so we can have a quick look at it. This again is the circuit of the unit in question. Power supply, of course, is okay on playback. On record it should be much less, but I'll check that. Now, playback, heads through to there, through here to there to speaker. That's simple. That's working. That's fine. Now, as far as oscillator is concerned, that's okay. We've heard it in bases. That's fine, but it doesn't actually record very well, does it? And so we look at the circuit. Now on record, it goes from here down here to the heads. Okay. On playback, it goes heads going there. On record, they go in there. Okay. That's how it operates, and of course the the audio and the oscillators are combined there, and there we are, it works. Anyway, so what are we going to look at? Well, first of all, I am drawn to those resisting that capacitor there, first of all. I really am. So those two resisting that capacitor. But so before we do anything like that, always when you're fault finding, check the simple stuff first, okay? And so the first thing what I'm going to do here is get me a switch cleaner, whatever it is. I'll get the ordinary switch cleaner, I think, and I'll give this switch a good spray. And of course, like that. Like so. Okay, so that's sorted. Now, as far as the voltages go, we are going to look very much, first of all, at that voltage there. Now, if the tape recorder goes back on its front, I can pick that up while the thing is on record by using the capacitor here, of course, which is this one here. So let's find a way of getting it into record with one hand, which is tricky on this, but we manage. Then we'll take it from there. Surprisingly, it's almost it's interesting, but there we go. So first thing we'll look at, of course, is over here, which is 229 volts and 202. That's okay. Okay. Right, now it does that good aim with that. Yes, it does. Okay, fine. So that's working okay. That's something. Right then, next thing we do is look for components, things that might need a little bit of contact cleaner on them. First of all, always check first of all the simple stuff. Always, don't go in with checking the simple stuff first. We've all done it. I have too, but you always check the simple stuff first, whatever it is. You would be surprised. It really would. I mean, really. Right now at this stage, the T-valves are out of the unit, and first thing I'm going to do is measure the grid capacitors again. Now the reason why I take the valves out to do this on a deck or a unit where the valves are in parallel is that if you look at the circuit again very quickly, there you are. You see, if you take the valves out of the circuit, all the current has to go through that capacitor, 3, 7 or 10, you see, it all has to go through those. Now in that situation we need, if it doesn't show anything, then we know the caps are alright. So that's the first thing we're going to do. So on it goes like that, and because it's got one of those bridge rectifiers, it'll grab them straight away. So from there, with the valve out, there should be a high voltage. There should be a high voltage. The meter's not playing up. What now? That's not doing anything either, is it? Let's try and find a better place to. There we are. Try that. Okay, we'll try again, shall we? Right, that goes to there like that. You see, and with the valves there, that will be high, even with the capacity to take it, because they've got nowhere to go. So now there should be a high voltage, which there is, and there. And if there's anything here, that cap needs to be changed. So into 2 volts, and I think that looks pretty okay, don't you? So that cap is obviously okay. Okay, and then down here on the ECC3, pin 1 should have a high voltage on it. Again, let's see if it does. It does. The grid has nothing, which it shouldn't have, because there's no voltage on there anyway, you know, but we'll check it anyway. Okay. Now, pin 6 should have a high voltage on it as well. It does. And pin 7, again here, very little. So we know that those 3 caps are okay. Now then, from that, therefore, we've got to find out why it works on playback but not on record. Now, the circuit here tells us that it switches other components in when it's on record. So if I was to do that, like that, it's on record, simple as that. Okay. So now, if you put a microphone on this, which I'm not going to do just yet, there should be voltage, there should be something on there, and of course we should be able to follow it to the circuit and see where it is leaving us, because somewhere it obviously is. Now in this situation, I think I might be lazy and use a scope. So just hold on a second, and I will bring the scope into play. I'm afraid I can't put that and the scope on the same thing, but I can of course see myself talking at this level on that microphone, and that is coming out to the ECC82. Now from there it goes into the ECLX6, which is there, like that, and as you can see, that too is doing extremely well for itself there. Very well, in fact. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. I'm not speaking directly into it here, but I'm getting a hell of a lot from it. So that is after the second stage amplification here. So on the other end of it, there should be voltage as well on. I think it's there. It is, right. So that goes to there, and of course from there it goes to there, and from there it goes up here into pin 10. So it should be something there or there, which there isn't. Okay, fine. Well, that's okay there. Okay. And the anode at the cathode side of that is pin 9, which is here. So 1, 2, 3, 4, that's okay. So that's okay. That isn't. That isn't. Okay, fine. Well, that means that it read okay just now, and it plays okay, but doesn't seem to do anything on the chords. So I don't know here. I really don't. So that goes to there. That's fine. And that then goes to here. That goes here. Okay. And from there we should get another capacitor. I'll just look at the circuit again and check that. C10. And that goes off pin 9 here, so that's going to be this one here, which it is. And that's doing nothing. And that's doing nothing. That's doing nothing. That's doing even less there, so also here too. Now then, is C10 after all the cause of our troubles, I wonder? What I'll do, I will change it and come back to you and see if that sorts it. I changed that capacitor, and the short circuit actually was because although I pressed it with a switch here, which I just did there for completeness' sake, it does actually also have a switch on the deck, so it mutes all the audio when the thing is in play or rewind. Now with that off, it is now rather a lot better. So if I now go and put that onto there like that, like so. Like that. You see also now that is registering again now. And also, if I was to put that onto, I don't know, there to start with, it's there. It's there. And it's there. Okay. 1, 2, 3. 1, 2, 3. So it goes to there. Okay, fine. Goes to there. Okay, fine. And also goes to there. Goes to there. 1, 2, 3. 1, 2. 1, 2, 3. Okay, fine. To there, like that. 1, 2, 3, 4, 5. There we go. And then it goes to here. 1, 2, 3, 4. That's lower, isn't it? That's lower. Right, okay. And it goes to there, where it is actually the bias is there, but there don't seem to be anything at all from the anything at all on the record. 1, 2, 3. I'd hardly get that, but if I go back here to somewhere like there, 1, 2, 3, whichever one it is, that one there first of all, that's the, oh yeah, that's not doing much either now, is it? Let's start again. Is it doing anything there? No, it's not. Is it doing anything there? Now it's how about there? Well, that's off, that's why. Always put the earth on and make sure it doesn't fall off. Right, okay, so now I've got it to there, as I see that, and it goes to there, goes to there, or doesn't, as the case may be. 1, 2, 3. 1, 2, 3. No. 1, 2, 3. It's there. to there, but it seems not to be going to here, which goes to the head as well. So it looks like it's these resistors, this capacitor here, that might be the next problem we have to sort. The thing is, the capacitors and the resistors in the circuit aren't the same as the ones in the diagram. Now either this is a later revision where they were lowered, or they're wrong, and they're wrong from the factory. It could be anything, that it really could. So what I'll do next is I'll lift one end of that off like that and see if any audio gets through to that point. If it does, then the next place we look is this switch on the back of the head, which I've been a bit suspicious about before. So but we're getting there, we're getting somewhere anyway. And now another fault has reared its ugly head. R12. There's nothing at all. There's a circuit, just a reference. There's nothing at all on valve on the ECC82, which is this here. Okay, nothing at all. And the fault is that resistor there, which is R12. Okay, and so that 22k resistor is now shot up in value and looks bad as open circuit. Now I've had fun with Unitra resistors before, so it wasn't truly unexpected, to be honest with you, but next thing we do is change that. Let's try again, shall we? We should now get something on there. I've changed that resistor down there. And we're back in business. Right, okay. Now then. What was I doing before? Yeah, I was looking through, finding out where it was lost, wasn't I? So yeah. Anyway, so it let's look at this again, don't we? Because of course I've forgotten now where it was losing it, if it was. Oh dear. Right, anyway. So 1, 2, 3, 4, 5. 1, 2. Ooh. That was okay. 1, 2. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 5. 1, 2, 3. 1, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. Right, okay. And compared to there. 1, 2, 3, 4. That's okay. Right, okay. So okay up to there. Right, okay. Now the resistor here. It goes somewhere like there. 1, 2, 3, 4, 5, 5, 4, 3, 2. That's low, isn't it? Okay. And here at the end of it all, 1, 2, 3, 4, 5, 5, but nothing else. Okay, so it's something around here. Okay, right. Well, we know that it was okay here. 1, 2, 3, 4, but considerably lower there. Okay. Now there's two capacitors, two resistors, and a capacitor here. And if I get the circuit, it's the two I was looking at early on. So R25, R35 and R13 with a capacitor in the middle. So first of all, let's have a look at those two, shall we? One is 27, one is 270 kilohertz K, the other one is 18K, and the capacitor in between. Well, first thing I'm going to do here is take the capacitor out of the circuit, because capacitors, generally speaking, are more trouble than resistors. So I can get rid of this here, the one it is, and see what that does. So it goes to deck as well. So I think it's that one. Okay, so we'll lift that one out, and we'll see if that brings it back up again. Okay, right, let's try that again, shall we? Okay, right. Don't want to come that, does it? Okay, not to worry. More than one was to skin a cat. So for the cost of a capacitor, I think we might possibly there we go. Right, okay. Now 1, 2, 3, 4, 5. When it comes up, one, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. I think I might just change all three of those components just to be on the safe side here. So it's M27, that's 270K, and M18. And we'll see what they come up with, shall we? So it's okay there, but reduced there. I'll lift that capacitor and it's still reduced. So I'm going to change that, and that for the what is on the diagram, and we'll see what happens from there. This machine is playing rather hardball with us. I've changed the two resistors and the cap, like I said before, and now if we put it on like that and put the scope back in, which it should be, hang on, okay, now then, I can see myself on that there, you see, talking away. So now I've got it there, okay. I've got something there, but I've got nothing here at all. Now if you take that resistor off, I get it. So as soon as that is made up there, then it fails on me. So why would it do that? Well, look at the circuit again. The next place it goes is that thing on the front there. So I'll check the wiring through to the front and check that nothing is shorting around there. And if it is, then let's find our problem. If not, yeah, a final technique to prove that it isn't on this board anymore. 1, 2, 3, 4, 5, and the scope shows it, and this here is disconnected here. Now if I was to put this back on here, I've put that back on, which I'll do in a second for you, it will probably go again. So I'll do that and we'll see if it goes away again. If it does, then we know the problem is up here. But I notice it's stuff that is coax, and so it might possibly be a short in the cable. It does happen. So what I'll do is I'll just connect up the inner and we'll see what it does. Well, now we've got another issue, and it's all to do with this switch here. Listen to this. That's both tracks together, but at that point there's no actual track going in from down there. There's nothing come from here. We shouldn't be anyway. But if I switch it into one of the tracks like that, listen to all that. There, oh, it's completely gone, that. No. But it's okay there. Except when it isn't.
His father thought he apprenticed him to some career seafaring. I was a lucky.
Now at this point, therefore, I've got to look at the diagram again now. Now, with it, when it goes onto ordinary playback, it comes up here, through here, and it goes on to there, okay? I'm going to I'll get the circuit and go through it with you. Right, okay, right, well here we go. I've changed these components here, you see, and it goes down here, like that. And it comes from here, you see. Now on playback, this should be out of circuit here, because that goes across, you see. That goes across there like that for them, back across there. It doesn't, it goes through here to here, okay. Now then, so we know that that's okay, and these only come into use on playback here. Now then, this particular tape recorder, the track switch here goes 1 and 2, 3 and 4 or dual, which is 1, 2, 3, 4 and dual in the middle there, which I'll point out in a second. Now, on the dual track, like this, it does actually play. It will do when it warms up. But not there. But the problem with that, as you heard there, is that on dual track, the other side comes in backwards as well. So that will not work basically in that sort of a way. Now, well, the head's okay, we know that because it plays actually very well actually, and everything else. So yeah, so it goes. Basically, if you look at the circuit here, I wonder if I can bring it in a bit more for you. Hang on, I'll see if I can. Like I was saying, on playback, it switches between this valve here, switches here, between play and record here. So on record, the heads are disconnected completely from the playback end, and it goes like that on playback, okay? On record, there has an outer circuit there, but not. But but on playback, of course, it goes up and across like that. Simple enough. On playback, that's okay. On record, this pencil circuit here, as I've said previously, operates as an oscillator circuit. Yeah. Now, also on playback, that's okay. On record, 1, 2, 3. From here, it goes down here to there, to there. Okay, that's how that works. Okay, so that's fairly simple. Okay. Now, when here with this lot here, it's okay on dual track as I said, but put it on an ordinary track like that, and it doesn't seem to want to know. As we'll see. Look at that. And both tracks are the same. So therefore, we know from that that this switch here, the track switches obviously from 1 and 4 to 2 and 3 track or dual, and that appears to be the problem here. Now then, one of them goes in on top of that head there, the other one goes there, you see, and that is done by this switch here. Now with it in dual, this lot is switched out circuit, including the oscillator circuit, obviously. But on playback, it goes to one or the other on the oscillator circuit. So what I will do, therefore, there is the two capacitors on the board here. I just take that off very quickly. The winds are right, but winds are right anyway. Like that. So they can come off, like that. They can go off for now. And here there are two. This is also controlled by this track switch here. This switch is the record oscillator from one track to the other on both the erase head and of course the bias on the playback and record head. And so I think the next thing we need to do here is have a good close look at this lot here. Right, okay, that's out of circuit, so now it's playback only, so let's see what happens. That is on the D track. Oh dear, oh dear, oh dear. Nothing doing now. Not doing even less. Well, that's okay. Interesting one, isn't it? I've got rid of the problem with the track control. I demonstrate. It was simply a wire that would come off down there. So anyway, that is dual track. That's 2 and 3. That's 1 and 4. Or 1 and 2 and 3 and 4 on this, but it varies from machine to machine. I'm used to 1 and 2. 1 and 4 and 2 and 3 because that was the chip card I had. It was a them. Doesn't matter, you know.
Right through being hard of hearing,
so there you are, that's that sorted again. Now then, the next thing we got to do is see what the record's like now after I've checked all that and see that works okay. So another tape goes on and we'll see what record's like. So switch to record first of all on 1 and 4 track, and we go hold that down like that, and of course then we go and start. And 1, 2, 3, 4. A bit difficult with one hand. Here we are. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. That sounds alright to me. Now onto the other track and same again. 1, 2, 1, 2, 1, 2. It's just me here with this. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. That's okay to me, and I hope that's okay to you as well. Now then, with the electronics all sorted out, we haven't as yet got the belts yet for this. So what I'm going to do, I'm going to leave it here and come back tomorrow with either the belts for this or some that will do, and show you how to change the belts, because you don't lift all this off. You don't. If you do, all this one day will fall apart, and you have a horrible time putting it back together again. I should know. I've done it, and so because I'm such a nice individual, I'm going to show you how to do it without having all those problems. With these machines, you can either take the whole top off and fit them in that way, but all sorts of things can fall apart, so it's not the best way to do it, although some people have. What you do, you look underneath, you find this with 2 screws here. Now this is actually under here, the bottom of it, bottom of the large wheel here that basically takes the motor, drives the capstan and idler, and from that it takes another belt up to the take-up spool to spin this round to make it go. So you take this one apart carefully, of course, like this. These come out. These screws come out. No, should do. Well, there's one. Okay. The other one is a little bit more troublesome, I can see. So again, this one also comes out. Like that. Yeah, so they come out. That comes off. And under there, you see, is the centre of that wheel underneath here. You see, it's here. Okay, with this job. Now, as far as putting the big one on, which is not here, and the small one, the big one has to go on first. The big one is here. The big one goes on first, without saying. Then the second one goes through here and goes up towards the the spindle here. It's quite quite reasonable to do, you know, so it's not much of a problem. But now you see what we do. We take out this band here, we take it off around there, like that. And it comes out from underneath. Now we get our new belt, wherever it is, and put it in. I did get the replacement belt from wherever it is, and it's on the floor here. So that then goes up like that, up there like that. You see, and goes onto there. You see, like that. So that is now in place. Okay. So what I'll do, I'll put this one on very quickly. It'll further come off again in a minute, but I'll put it on again for now, like that. And what it will do is it will hold that in place while the tape recorder is turned over and the other bit of the belt is put on around the tape cut spindle. Okay. Now, when that happens, what we do, we take out one and we put in another one. It's as simple as that, and it's a hell of a lot quicker and a hell of a lot safer than doing the usual take the top off and everything through. You just don't want to do that basically. So you know you don't. Okay, so that's how you do that. So I'll turn the thing over and get back to you when it's turned over. Right, well the problem with it going fast forward on stop and all that is actually due to the fact that the belt I've put in, so it's only put a small amount of pressure forward on here. It puts a little bit more on. Now because of that, I'll have to walk this again sometime soon and change the belts properly, but I've shown you how to do it, and of course now it's working on both tracks, which we'll see presently. Because unfortunately this particular machine is a two-track machine, so unfortunately. So that proves that it worked on all bands. Anyway, I'll put it back together again, and once it's put together again, we'll give it one last try. And here it is. It's a Unitra ZK140, which is the Unitra version of a Grundig, made with all Polish Unitra components on the electrical side, which do give problems. Capacitors not so much, but certainly resistors do. Now I've had to change quite a few. I have to change that, change the parts on that board, as you know. I've had to do something with the tape transport for now, but when those belts come back in, I'll take over it and do those properly. And of course it now plays. As you can hear. There you go, that's it, that's the end of Pirates of Penzance there, and there you go. And there's the other side. So there you are, a working machine again. Quite a bit wrong with it, but okay, that's working now. Okay, fine, fair enough. Well, that's good to know. So anyway, I shall now take all this off here for now, like that, and when the replacement belts come, I'll put them on, and it'll be a fully working machine. But for now, it's a machine that works, but not properly, as you've heard. Anyway, that's it for now with this. But I kept the stickers on, by the way. It's on the side here. Niggering, all in skis. That's a Coca-Cola. I don't know what that one is, but Coca-Cola one's interesting. I wonder if I can get back in and have a look. Hang on, I'll see if we can zoom in on that. I don't know what that is, but it's obviously Coca-Cola. So normally I would tend to take stickers off units like this, but I don't know what they are. So there you go. Anyway, there it is, working, happy-ish, and I'll get back to this when the belts come. So until next time, here at Steve Pendlebury's Vintage Radio Longstay Workshop. Goodbye, and I'll see you soon. And keep fixing radios wherever they are. Take care and bye bye. Bye bye.